I'm the teacher right now, and I'm teaching you fluid mechanics for my exam on Friday. Okay, so what we've reviewed so far is force is equal to mass times acceleration. But it's not just the force that's equal to mass times acceleration, but the summation, summation of forces equal mass times acceleration. So moving on from there, what is mass? Well, in English units, in SI units, if you will, kilograms. And then US custom, it's pounds, LBS. So then acceleration. What is acceleration? In SI units, kilograms per second squared. English units, what would it be? Pounds per second squared. Yes. Got confused there. Pounds per second squared. So now we have all these numbers. Okay, so now let's move on. Let's move on to units. Because units will clock ya. You get them wrong, answer's wrong. Boom! Building fall down, people die. So, units, important. So, what are units? Acceleration, like I said, meters per feet square, don't even play with me right now. Acceleration in SI units is kilograms per meters squared. And in US units, it's pounds per feet squared. Volume, meters over seconds. No, velocity. Velocity is meters per second and pounds per second. So, mass. What is mass? That'll get you. 'Cause mass, kilograms. You're a kilogram when you are not in the United States. When you are in the United States, do not, never, ever think that a pound is a unit of mass. Pound is not a unit of mass. Pound is weight. Weight does not equal mass. Weight does not equal mass. Do not play with me like that. But what is that, you know? Because if I'm out there in Croatia, I weigh some kilograms, I don't know. But freak, I don't know what that is in the US system. That's when we whip out our slugs. Love our slugs, okay? I'm actually gonna bring you a little bit closer so you can see my drawing of a slug, which I already taught the class earlier, but I can teach you again. Our slug, we have our slug. Yay! We have our slug that's exerting some sort of weight. So we have our pounds within our slug, and our slug moves forwards at seconds squared. And all of this is over a distance, feet. So mass in US units is pounds second squared over feet, just right here that you probably can't see. But a slug is pounds second squared over feet. So that's my little diagram of how I'm remembering what a slug is. Then moving on, we got our forces. Forces is newtons or kilonewtons, because they're kilos. You see this? A kilonewton is equal to 1,000 newtons. But because it's a kilonewton, gone. 1 kilonewton per 1,000 newtons, because they're kilos like that. They killed them all off. Don't even play. So that's what I got here. 1 kilonewton, it's 1,000 kilonewtons. Okay. Where'd my paper go? Where did my review paper go? You want my mind go tomorrow. Oh, here we go. Okay, so if we got newtons in Croatia, and the British have kilonewtons, what do Americans have? Pounds. Oh, tricked ya, huh? Tricked ya. Forces in pounds. That's why we have this wacky conversion. This ain't the same. Don't ever get them mixed up, okay? Or you will regret it. Okay, yeah. So now moving on. Like I said earlier, that weight does not equal mass. Weight is not mass. Do not get them mixed up. But mass is weight times the gravity. Because what mass is you have something. The mass of this expo marker does not change anywhere. It doesn't change on Pluto or in space or on the moon, anywhere, because the mass of it, how much of the material is within a certain space, does not change. But the weight of it changes based off the gravity, because on Earth, my mouth is dry. On Earth, it's 9.81. I don't know what it is anywhere else, but I know it's not 9.81. So that's why the weight changes as you go other places. I don't know. If you guys ever go to Pluto, let me know. That's actually so sick. Okay. Okay, perfect. Moving on. We have to make our toolbox. We can't never, ever forget the toolbox. Because we need our supplies. You know, if you want me to go solve this problem, if you want me to be like, ha, I got this, I'm not going to pull up to a problem without my supplies. Freak no. So this is what we got. Toolbox. What we got in here? Force times mass acceleration. Force, summation of forces is equal to mass times acceleration. Clock it. What else we got in here? We got kilonewtons, but that, you should just know that. But that's not in our toolbox. What else we got? Oh, Manning's equation. Oh my gosh, who's Manning? Is that guy from? What show is that? Manning's equation, Manning. Something family. Freak, I don't remember. Anyways, Manning's equation is, I was gonna look at it, but I could tell ya. Q is flow rate. Trust. So this is fluid mechanics. I'm not sure if you clocked that in the beginning. This is fluid mechanics. So the flow rate of liquids is equal to 1/n times the area of the channel it's flowing through, like something, I don't know, times r to the 2/3. What's r? I'll get to it. Times s to the 1/2. Oh my gosh, isn't s to the 1/2 just square root? Yes. Anyway, so we have this. So what's r? Actually, what's a? What's area? Well, I hope at this point in all of our lives we know what area is, but just in case, area is the width times height, aka, yeah, width times height. But what is r? R is equal to, okay, I'll see right now. Area is equal to the width times height, and r is equal to the area divided by wetted perimeter. oh my gosh, what's wetted perimeter? Let me tell you. So, say I have this channel and I have water flowing through it. And the water is up to right here. If it's not fully at the top, say this channel is 9 feet deep, but the water is only 6 feet deep. And then we have the length, the width, I don't know, let's have it be 5. The wetted perimeter is the perimeter that the water is touching, okay? So, clocked how I said 9 feet for the hole, but it's only 6 feet tall or deep. 9 minus 3, guys, we're only using that 6. We do 6 plus 5 plus 6. Don't let the total depth of the channel fool you, because the water's not touching that extra 3 feet. Ain't doing nothing. So, the wetted perimeter in this case, like I said, would just be the 6 plus 5 plus 6. Right there. Trust. So, we have that, and now it's less. Oh my gosh, this is the door to my bathroom. My roommate meets in the bathroom. Ooh, this is not a good. Hey, you know what? I don't care. I'm teaching y'all food mechanics. S. What is S? What is S? I don't. Wait, no. Let me lock in, guys. Trust. I know what S is. S is the. Oh, did I even look on the back? Oh my gosh, I didn't even look on the back. Pressure, moment, torque work. Okay. Push and P. Okay. What is S? I'm spacing. It's in my homework. Freak. And it's not hard. It's not hard to solve. Let me find it real quick, actually. Oh. Brother. Okay. Okay. I'll use the example that was in. So S is slope. So in the practice problem, it was if you had it slopes 0.1 foot over the span of 100 feet. So the slope would be 1.1 over 100 feet. Because if you think slope doesn't have units, right? Like these units would cancel. And then this would be 0.01. So yeah, it should be unitless. Okay, you got it? Now we add this equation to our toolbox, because I'm not trying to go into this test unprepared. I need my preparation. 1 over n, a r 2/3 s1. And don't let it trick you. The one that's 1 over n, it changes. 1 is for if it's in meters, and 1 for meters. Oh my gosh. But 1.49 if it's in feet. Clock it. Okay, moving on. Okay. Okay. Are you kidding me? Okay, now we've got hydraulic radius, or equals area of a wetted perimeter. We just learned that. Oh, and that's what R is. I didn't even say. R is the hydraulic radius. As confirmed in my notes. So, oh yeah, so if we're looking at a pipe, because like in that example I showed you, that it was a channel. It was like a square, basically. It was no top. I don't know what you would call it, but now we have that. Now, what happens if that's in a pipe? I keep sticking my tongue out. Anyways, okay. So we have a pipe that's filled with water. We have our hydraulic radius of area over wooded perimeter. That's a pipe. You know, how are we going to solve that? Well, take the area of the circle, pi r squared. Hope y'all know what r is. Radius over wooded perimeter. And what is wooded perimeter? Circumference. Which I actually always forget the circumference. 2 pi r. I need to remember 2 pi r actually, because I'm not that great at it. I'm actually going to put that into my toolbox. For some reason, I've never really remembered it, but we're locking in. Area is equal to pi r squared. Circumference is 2 pi r. Okay. Okay, but now we gotta pi's cancel out. The square and the r cancel out, so that's just r over 2, which if you multiply it by 2, it's diameter over 4. These two are the same. And this applies when it's even halfway full, because pipe is proportional. It's halfway full versus when it's full. Proportional, not the same number, of course. I don't know. I'm getting tired, you guys. But my alarm hasn't gone off till when I can stop setting. So we keep going. So we have radius for pipes if we need to solve that. Oh, okay, now we have our MLT and FLT. Oh, what? What's an MLT? Oh my gosh. Well, let me tell you. MLT, FLT. Mass, length, time. Force, length, time. Trust. So, these are dimensions. Okay, these are dimensions. So, when someone asks us, what is force times mass? Force equals mass times acceleration in a dimension. Well, a force is just a force. Oops. So we leave it as a force if you're keeping it in force, FLT. But what's mass? Mass, would that be force? Oh, well, I lied. We're going to do an MLT. So mass is mass. But what is acceleration? Acceleration is equal to mass over seconds squared. So if it's mass per it's not mass. Oh, I'm tired, guys. I'm so tired. Meters per second squared. So that is length. A meter is a length. Seconds is time squared. Boom. Force times Newton's second law in terms of MLT. Trust. Okay, yeah. Force. Let me see if I can find a force out of this problem. I don't know. Oh, okay. There's our class. Like, I freaking remember doing practice problems. Okay. So, volume. Volume is length cubed. So what's that in terms of MLT? Length cubed. No, the same value, same number, so it doesn't change. But say we try to find acceleration. So acceleration is equal to, oh, we just solved that, mass per second squared. Meters per second squared. Meters, length over t squared. Okay, wait. We found that weight, is this pounds? Wait, okay, we found that weight is equal to mass times gravity. Mass we found is mass. Gravity is meters per second squared as well. It's the acceleration at which we fall to the ground. So I am, in this moment, gravity's pulling me down at 9.81 meters per second. And what did we just talk about? Meters, L per second squared. Oh, trust. So this is weight in terms of dimension. And we use this like little equal symbol with a dot on the top. Okay, and now, okay, pressure. This pressure. Pressure is equal to force over area, specifically when it's perpendicular to the perpendicular to the area, to the material. Let me triple check that. Yeah, and then because shear stress is parallel to it, that makes sense. Okay, anyways, I'll just do a little, wait, parallel, where are you, parallel? I'm looking for you. Okay, yeah, like imagine this is the box. It's going against the area, but here it's going with the area. Just trust. So it's force times times area. We found that force is equal to mass times acceleration, and area is equal to height, length times width, mass times acceleration, MLT squared over length and width are both forms of length. So now 2L, or we could do L squared. I'll write 2L for technicality reasons. I lied, I will not write 2L. I will write L squared. Because no, it's right there. L squared. Oh no, this is T squared. What the heck? L, that cancels out though. So now we have mass, don't forget little dots, mass over LT squared. You get that? Mass LT squared. Perfect. Okay. I believe okay, perfect. Keep that up there so you can get your notes. So I went over this. So now it's time to go over this. Height. Oh, I went over the hydraulic radius for a pipe. Period. Oh, density. Density is described as phi. Okay, I'm gonna actually stop the video.